Hello engineers, welcome to the new video of the course, and in this particular video we are going to simulate these circuits onto the Proteus and also onto the Tinkercad software. Why we are simulating these basic circuits onto the Proteus and the Tinkercad software? Because I want that you should be very much comfortable about these two instruments, like how exactly we are plugging these two instruments into the circuits and what exactly they are doing, right? How exactly they are detecting the current and voltages respectively. So this is our agenda for this session. Okay, so for that let me go on to the Proteus software. Let me tell you that in this course I have not covered Proteus software. Okay, but if you go further in some other course, let's say in course of bipolar junction transistor, I have covered this particular software in detailed way, right? All in and out about this particular software in detailed way. So as of now we just focus upon this particular circuit. Okay, it's fine even if you don't have any idea about Proteus software. We are just going to simulate the circuit and we'll just check if we are able to detect the values for current and voltage. Okay, sorry. So yeah, this is the circuit. So you see I have voltage. Let's say the voltage is of 9 volt. I have connected this 9 volt of battery. This is my load resistor, right? This is my load resistor. Okay, so let me just write over here, or in fact let me just change the name. So this is my load resistance, so I'll write it as RL, load resistor. Okay, and load resistor is of 1 kilo ohm. Okay, now as clearly mentioned that if I want to measure the current that is flowing through this particular load resistor, so I just need to connect this particular ammeter in series, right? I just need to connect ammeter in series. So you can clearly see this is my ammeter. As you can see, amps, this is nothing but ammeter, and you see this particular instrument. What is this? This is my voltmeter, because it is detecting the voltage across this particular load. Voltmeter. Okay, and you can clearly look over here. This voltmeter, it is connected in parallel with the load. Okay, in parallel with the load. Okay, whereas you see this one, this ammeter, it is connected in series with the load. Okay, so just by looking at the circuit, I hope you are able to understand that how this ammeter and voltmeter, it is connected to the load. Okay, great. So now we'll just run this particular circuit and we'll just check if this two instrument if it is able to detect the current and voltage through that particular load resistor. Okay, so let me just run this particular circuit. All right, so you see we are able to detect the voltage, that is 9 volts, which is coming across the load, but somehow we are not able to detect the current. What can be the reason for it? Well, the reason is quite simple. Just pause this simulation and just double click on it, and instead of amps just make it as milliampere, because the current is in few milliamperes, right? Now you just run this particular circuit and you are getting the value for current, which is 9 milliampere. Okay, so this is how the values for this is how we obtain the values for the current and voltage. Okay, I hope you are able to understand this. Okay, so now what we are going to do, we are just going to implement this basic circuit onto the Tinkercad software. Now why we are implementing this basic circuit onto the Tinkercad software? Because you see over here we are just getting the symbolic representation of voltage, of this particular ammeter, voltmeter and load resistor, right? But believe me, whenever you are trying to just implement this particular circuit onto the breadboard, it will be little tedious at first glance. Why? Because you will not understand where the hell is the positive terminal of the battery, negative terminal of the battery, how should I connect the ammeter and voltmeter and so on. So there will be a lot of confusion, okay, whenever you implement such kind of circuits in the real world. Okay, over here on softwares like LT-Spice, Proteus, it becomes pretty easier, because they are just, for voltage you just get a symbolic representation of voltage, you don't get a battery, right? Okay, but things changes as you open a Tinkercad software. Okay, so how we are going to how we are going to proceed further? So first we will just connect this part, that is battery and ammeter. Okay, so let's go on to the Tinkercad software and let me just take a 9 volt of battery. I'll just keep it somewhere over here and I'll just rotate this battery. Okay, great. Now what I can see over here is my battery. You see the positive terminal of battery, it is connected to the positive terminal of an ammeter. Great. So let me go over here and let me just search multimeter. Yeah, so I'll just click on multimeter. I'll keep it somewhere over here and then what we saw, positive terminal of voltage, that is positive terminal of battery to the positive terminal of ammeter. Okay, so positive terminal of ammeter to the positive terminal of battery. Okay, I hope you are able to understand this. Great. Now you see the negative terminal, it is connected to the load, that is some resistor which is of 1 kilo ohm. Okay, it's fine. So for that we just need to take a resistor of 1 kilo ohm. So I'll just place this 1 kilo ohm resistor over here. Okay, by the way, if you want some other resistor, let's say 100 kilo ohm, you have that privilege to change the value for that resistor. In fact, if you want in few ohms, you can do that as well, in ohms, kilo ohms, mega ohms, giga ohms, etc., right? But as of now, we want the resistor of 1 kilo ohm, so I'll just put it somewhere over here. I'll just place it, and then the negative terminal of this multimeter, I'll connect it to the to this particular resistor. Okay, and by the way, let me just change this multimeter. I mean, it is right now it is detecting the voltage, as you can see, so just change it to amperage. Okay, so then it will detect the ampere, and you just see this multimeter, now it will check the amperes. Okay, great. Now, so now that we have completed this part, and yeah, the other part of the resistor, it is connected to the negative terminal of the battery, right? So it's pretty simple. The other part of the resistor, it is connected to the negative terminal of the battery. So it will be something like this, right? It will be, one second, it will be something like this, negative terminal of battery. Okay, and we are left with one more part, and that is to represent the voltmeter. So voltmeter is connected across the load. Okay, so again I'll just click over here, I'll just type multimeter, and yeah, just place it somewhere over here, and it is connected across the load, right? Just something like this, and I'll just put it somewhere over here. Yeah, so you see the positive terminal of voltmeter, it is connected over here, and the negative terminal, it is connected over here. Okay, so this is my positive terminal of my voltmeter, so I'll just connect it somewhere over here to this particular resistor. Okay, and the negative terminal of this voltmeter, I'll connect it to this particular part of the resistor. Okay, I hope you are able to understand this. Okay, now we have completely designed this particular basic circuit onto the Tinkercad software. Just look at this particular circuit. I know at first glance it might look little tedious to you. Okay, to understand this, it looks little complex, right? As compared to this circuit, it's very basic: voltage, ampere, load resistor, voltmeter, that's it. But you see over here, at first glance, if you are new to the electrical circuits, it becomes little complex, it becomes little tedious, right, to understand it. But now I hope you are able to understand this circuit. It's very basic circuit. Okay, now that we have connected each and everything, we just need to start this simulation. And yeah, you see the current is 9 milliampere, 8.99 milliampere, which is approximately 9 milliampere. The voltage is 9 volts, right? And in fact, if I run this if I simulate the same circuit onto the Proteus software, we are getting almost same values, right? 9 milliampere and 9 volts. Okay, so yeah, this was all about the session. I believe that now you are able to understand that what is voltmeter, what is ammeter, how exactly we are connecting both of these instruments or devices into our circuit, okay, to detect the current and voltage that is present across the load resistor. Okay, so I really hope that you understood and you enjoyed this particular content. But still, if you have any doubts, if you are facing any difficulties anywhere, it's my request to you all guys that you please ask those particular doubts into the communication section, and I will be happy to help you out there. So thank you for listening me patiently. I'm ending this video over here. Thank you.